I want to talk now about using Action Reducer and the potential vulnerabilities there. And so we're looking particularly at action processing and queue management. And some red flags here are if we have unbounded action processing, if we don't have proper validation of action data, if we have improper action state management, or we have actions that could cause arithmetic overflow. We could test this by flooding the action queue with malicious inputs, and the question to keep in mind is, can malformed actions cause a denial of service or state corruption? So to dig into this a little further, we have the action reducer pattern, but we have to be careful about vulnerabilities when we're using it. So we have to make sure that actions are validated. We have to be checking for denial of service attacks caused by limitations from the queue. Also, when we're managing the action state, that has to be done properly. And we have to be careful about potentially malicious actions or actions that are invalid. So I've got an example here of a vulnerable pattern. So here we're doing a reduce, we're getting actions, but we are vulnerable to a denial of service because there is no limit to the actions that we are going to be handling. Furthermore, there is no validation of the action data. So if you want to test this, if you think that this is a possibility and you want to find out some ways to do that, would be to have a very large action queue, so flood the queue up to the maximum number of actions that are possible. For the actions that you've submitted, try putting in some extreme values and seeing if they are being handled correctly. As well as having valid actions within the queue, input some invalid actions and see if they are being handled correctly. And also look for action replays. This is something that people tend not to think about, but see what happens if the same action is replayed a number of times. So the overall approach then is to submit actions that could cause some overflows, for example, or some type of denial of service, and this would reduce the resilience of the reducer.